Okay, on the sample exam, numbers 1 and 2, you want to be able to find the determinant of the matrix by using row reduction. For whatever reason, um, people tend to make this an issue. um, well, let's see. So what I'm going to do is to use that 1 to get a 0 where this 1 is, and use this leading 1 up top to get a 0 where the 4 is. If we can reduce the matrix to a triangular form, then you can just multiply the entries along the main diagonal and get your determinant. -7, 3, -4. It's +3 and 1. We get 4. Here we're going to multiply by -4 up top. So this is -20. We get 12 and 1, 13. So I suppose we can use this -4 to our advantage to get a 0 where that -20 is. So if we just say 5 times row 2 plus row 3. It'll be positive, it'll be -5. So -5 times -4 is +20. So we get that. -5 times 4, -20. And then plus here the 13 is the -7. And so indeed, now multiply the 1 times the -4 times the -7, and you get 28. Now, in terms of reducing, let's see. Okay. Um, it did say use row reduction. I almost forgot that. I was going to take 3 times column 2 and add that to column 1 to get rid of this 3 and that 3 to get zeros and zeros. And then I was going to use cofactor expansion on that position right there. But it said use row reduction, so sorry. you do know that with the determinant, the rules also apply to column reduction as well. So you can use row reduction, column reduction is still fine. So here I'm going to interchange rows 1 and 2 to get that leading 1 up top. So negative in front of that. When you interchange rows for the determinant, you negate the determinant. We can use that negative to our advantage. So we just say 3 times row 1 plus row 2, and then 3 times row 1 plus row 3. Yes, sir. Yes. The question is, why did I put a negative in front of the, that's not a matrix anymore, it's the determinant. Put a negative in front of the determinant. If you interchange rows, you negate the determinant. It's a theorem. Do you have your textbook with you, Daniel? We went over it in class, um, but on page 114, Theorem 2.23, Part B says that if B is the matrix that results when two rows or two columns of A are interchanged, then the determinant of B is equal to negative times the determinant of A. If you interchange two rows, negate the determinant. Interchange two columns, negate the determinant. Now what's fancy about that is you can interchange two rows here, interchange two rows down there, and it's negative times negative is positive, right? So it's page 114. Theorem, what did I say? 2.23. That's part B. Okay. And so now we're going to say 3 times row 1 plus row 2, 3 times row 1 plus row 3. So it's negative out in front, negative 1, negative 4, negative 2. So it's 0, we're saying just 3. So negative 12 and negative 1, negative 13, 3. This is negative 6 and negative 3 is negative 9. Get a 0 there. 3 times the negative 4 is negative 12. Minus 1, negative 13. And then 3 and times the positive, well, negative 2 is negative 6 here, plus a negative 1 is negative 7. All right. So I'm going to say that this is the determinant of 1, 4, 2, 0, negative 13, negative 9, and this is 0, 0, and this is 2. You see what I did? What happened to the negative out front, by the way? Oh! Gotta try to wake y'all up, man. I don't know. Need to come bring my jokes in here and tell y'all a couple of jokes and get y'all going. Right, Luke? Oh, man, I love it. What happened to that negative out front? I had a negative right here, but it's gone now. Where did it go?
Negative 1 out of the first row.
I factor out a negative from that first row, right? So it's negative times that negative is positive on the outside. So then what I did now was I said negative times row 2 plus row 3. So that gave me a 0 here, obviously. Plus 13 minus 13 is 0. 9 minus 7 is 2. Now just multiply the entries along the main diagonal because it's a triangular matrix. 1 times negative 13 times 2 is negative 26. Okay. Any questions there? Oh, by the way, here's what I would do if I were you. On the test, when you're asked to solve for the determinant using row reduction, do that, but maybe on the side, solve for that determinant by a method that you like and compare to make sure you get the right answer. Right? So if your personal method for finding the determinant gives you 7, and when you did row reduction, you got 1 over 14, well, you have a standstill. Like in high noon, right? Boy, I tell you. So it's either the method that you preferred, that you went on the side and got the determinant, it could be wrong, or it could be right. Or the method by row reduction could be right or wrong. Right? Well, hopefully both ways you get the same number, right? Typically what I've seen is when people solve by row reduction and then they go on the side and they find the determinant by cofactor expansion or by the arrow technique, that typically that personal method is usually the right answer because you've done that before and you're kind of used to that. So if you kind of believe that to be the case, or if you're like me, if you get two different answers for the determinant for the row reduction and for the determinant for the arrow technique, you might want to try cofactor expansion, you know. And so if 2 out of the 3 are the same, and if this guy was wrong for the row reduction, go back and check your steps with that just to make sure. But I need to see that if I'm asking you to solve for the determinant using row reduction, you got to make sure that this is right. Right? Doesn't matter about what you do on the side. Check that by all means for yourself so you get the right answer. But you want to make sure that this is right. I had people to do this. I guess they think I'm dumb. They would get the determinant wrong by the row reduction form. Then they go on the side and they'll solve by cofactor expansion, get the right answer, and then just put that number over here and say this is the answer. But everything they got before that is just totally wrong. Yeah. Come on, guys. Jeez. That was a good try, but anyway. Okay, the last one here. Number 5. What you want to do is to first find the determinant of A, and then you see what this says. This says the determinant of 4A. We've got to interpret that. Okay. So let's first find, the determinant of A, and it's already set in that form to find the determinant. So here I'm going to use cofactor expansion. Let's do this. Let's take this 1 to get a 0 there, and then we'll use cofactor expansion. So this is 1, 0, 3, 0, negative 1, 2. Say negative 2 times row 1 plus row 2. So this is 0, 1, negative 6. So I use cofactor expansion along the this first column. So it's going to be just 1 times the determinant of the submatrix, the negative 1, 2, 1, and negative 6. So this is 12 minus 2. So I get 10. Oh, it's a 6, excuse me. I thought my negative 1 was a 2. So this is 6 minus 2. This old pen again doesn't want to work. It's 4. Now part A, it says the determinant of 4 times A. This is equal to 4 to the 3rd times the determinant of A. This was, I believe, section 2.2. There's a theorem that says that if you have a common number that's multiplied to each term in the matrix, if it's a 3 by 3, then it's that common term number raised to that 3rd power. If it's a 4 by 4, it'll be 4 to the 4th power. If it was a 2 by 2, it'll be 4 times 2. Right? So recall that the determinant of k times A is equal to k to the n times the determinant of A for A in n by n matrix. So here for part A, this determinant of 4A is 4 to the 3rd. And we got 4 for the determinant. So this is 4 to the 4th, or 16 times 16, or 256. Okay. Part B was a theorem that says that the determinant of A inverse is equal to 1 over the determinant of A. Well, we got the determinant of A is 4, so this is just 1 over 4. Now I'm going to add a part D on here because it just might be on the test, and I want you to see the difference before I tell you and mix this stuff up. Part C is the determinant of, this is the inverse of 2A. This guy here is going to use the theorem of how we got part B, but it's going to associate this 2 with the matrix A. And so, look, because notice that it is 2A raised to the negative first power, right? So it's just not 2 times A inverse. If that's the case, that's my next example. If that's the case, then the 2 to the third power will stay upstairs, divided by the determinant of A inverse. I'll show you that next. So this guy becomes this. This is 1 over the determinant of 2A. So this is 1 over 2 to the third, because it's a 3 by 3, times the determinant of A. So this is 1 over 8 times 4, get 1 over 32. Okay? Any questions there? Now I'm going to switch it up. So now, what about the determinant of 2 here, A inverse? Now, what this is the number 2 that's multiplied to A inverse. So it's still 2 times each term in the matrix. So I still have to factor out 2 to the third power. But 2 to the third power doesn't go downstairs because that 2 is not under the power of negative 1. So this guy is 2 to the third up top over the determinant of A. So this is 8 over 4, just 2. So you're going to watch out for C and D. Any questions? Okay. Make sure that I think the homework and the quiz has been set for October 31st, so you should be good to go for the homework and for the quiz. And just come to class on Monday, and we'll have the test right here, okay? Thank you. Hey, Trey, and if I can see you all, Tyler and Michael, thank you.